Howdy folks, welcome back. So in this video, I'm just going to go through the practice quiz 5, I think is what we're at. So again, just kind of go show you how I go about solving the problems. Again, per usual, I know that it's by no means the only way, and in some cases it might not be the way that works best for you. Again, as long as you arrive at the correct destination, you don't necessarily have to follow the exact same path that I took to get there. And if you're curious as to where to start, this is just kind of to show you how I go about starting to solve these problems here. All right. So the first couple questions here are dealing with arithmetic operations with functions. All right, so here we have two functions. So we have f of x equals 2x plus 5, and g of x equals x squared minus 3. And we're asked to determine the following. All right, so we're asked to determine what f plus g, so that's a new function. So what that function is evaluated at -3. All right, so to evaluate the arithmetic operation within a function here, you're just going to evaluate each of the functions at that given point. So in this case, we're going to take f of -3 and g of -3, and then you're going to do whatever operation you have in your original problem there. All right, so in this case, I'm adding the two functions, so I'm just going to add those two values together. All right, so when I take f of -3, so when I plug in -3 in for x here, we have 2 times -3, so that's going to be -6, plus 5 is going to be -1. All right, when I plug in -3 in for g here, we have -3 squared, so that's going to be +9, minus 3 is going to be +6. So you have -1 plus 6, which is going to equal 5 there. All right, and that's all there is to it. All right, so a similar process when finding the product function. So again, we're just going to evaluate each of the functions at that given point. And in this case, we're multiplying inside here, so we're just going to take the product of those two values. All right, so when I plug in 4 in for x up here, 2 times 4 is going to be 8, plus 5 is going to be 13, times, so when I plug in 4 in for x here, 4 squared is going to be 16, minus 3 is going to be 13 as well. So you have 13 times 13, so that's going to end up being 169. All right, and yeah, subtraction and division work the same way. So again, you just evaluate on the functions at the given points, and again, you just perform the indicated operation within the parentheses here. All right. Next question here is dealing with the composition of two functions. So with functions, you also have a special operator known as the composition operator. All right, so the way the composition operator works is you just work your way from the inside out. So you start off, you evaluate the inside function at the given point, and then you take whatever value you have there and you plug it into the outside functions on there. So in this case, we're going to take f of x, and then we're going to take whatever we get for f of x, and we're going to plug that in to our function g. All right, so in this case, f of x is 2x plus 5. So we're going to take g of 2x plus 5, which when I plug in 2x plus 5 in for x with g, I end up with 2x plus 5 squared minus 3. All right, which then we just need to perform some of the arithmetic here. So when we take 2x plus 5 squared, that's the same as saying 2x plus 5 times 2x plus 5 minus 3. So we end up with 2x times 2x, that's going to be 4x squared, plus 10x, plus 10x, so we're just foiling this out here, plus 25, minus 3. All right, so we end up with 4x squared, we can combine like terms, plus 20x, and then 25 minus 3 is going to be plus 22. And the last one here is dealing with transformations of graphs of functions. All right, so here we have a graph of function g of x looks like this, and we want to find what the graph for negative g of x plus 2 minus 3 would look like. All right, so yeah, so we have a couple changes going on here. So the negative sign out front means that we're reflecting across the x-axis. So instead of my graph being a downwards triangle, it's going to be an upward triangle there. All right. So that's what the negative sign out front means. If we are adding or subtracting inside the function, so inside the parentheses here, so here we're adding 2. So adding means that we're going to be shifting the graph to the left 2 units. If we were subtracting inside here, we'd be shifting the graph to the right 2 units there. All right. And if you're adding or subtracting outside the function, so outside the parentheses here, that's when you're dealing with a vertical shift. All right. So if you're subtracting, you're going to be shifting down that many units. So in this case, we're going to be shifting the graph down 3 units. If we were adding 3, we'd be shifting the graph up that many units there. All right. So yeah, so again, the main thing I look for is I kind of look for the vertex or the intercepts, so kind of those points that are really relatively easy to find here. So yeah, so instead of going through the origin with my vertex here, I'm going to shift that point to the left 2, down 3. So that's going to give you down to -2, -3 there. And then for the reflection, again, instead of being a downwards facing triangle, it's going to be facing upwards. So something akin to that. All right, so again, I mainly only look for just like a single point, and then again, which way the graph is facing. So it doesn't have to be an exact point-for-point match there. It's just kind of a sketch to get the idea of what the graph or the function looks like for that. All right, yeah, those are the 3 problems. So yeah, so hopefully you found this helpful. Have a lovely day, and I'll talk to you all later. Bye now.